there. Thank you.
Okay, great. And so before I start, I wanted to take some time to talk a little bit about artificial intelligence and how it connects with computer vision. So I'll be talking about this under the explanation while explaining what computer vision is about. Now, artificial intelligence is the ability of making your machines intelligent. And when I mean intelligent, I mean being able to replicate the same things that humans can do, being able to do things, the same exact things that humans can do. Now, the question is, what can humans do? For us, we can see, we can talk, we can hear, we can touch things, we can feel, and then our brain also helps us think. When we get information, we can also respond to the information in the correct time. And so what basically artificial intelligence does is tries to replicate human intelligence in machines. So making machines behave exactly the same way as humans would behave. Now, one of the characteristics, as I mentioned, of a human is the ability for us to see things, not just being able to see things, but to understand what we have seen. And then if there is a need, tag along, have a specific tag for that image we have seen, and then use that tag, to identify that image subsequently in future cases. Now, the aspect of technology which focuses on this same thing, which tries to replicate our sight organ, is called computer vision. So computer vision has to do with machines being able to replicate the way humans' sight works. Now, how does computer vision work? Here is a brief summary of how computer vision works. So the first thing, there are two types, or there are two ways you can build your computer vision systems. First one is through machine learning. And as you know, or as the name implies, machine learning has to do with your machines, your software solutions, not just your physical machines, not just robots, but then your software solutions being able to learn. To be able to make this happen, you give an input, and then you as the human extracts or tries to figure out the different features between the different inputs. So for example, you are imputing your image is into the system. You are building a system, of course. You are building your image. You're trying to find characteristics between the different images yourself, and then give it over to the machine. So for example, an apple is an orange is round. um, then you could also say, let's say you have another image of a purple, for example. It is spherical in nature. I'm sorry, oval in nature, not spherical. Yeah, you identify all of those key traits, those key features in these different images, and then give it over to the image. Oh, sorry, give it over to the machine learning system that you're building. And then what it does is it classifies them based on those features that you have identified, then gives an output. But then this is difficult because there is interaction with humans. And what artificial intelligence basically hopes to achieve is removing that interaction with humans. So I don't have to program the system. I don't have to, impute details, too much details into the system. The system does it. The system trains itself. And that's where another aspect of artificial intelligence comes in, deep learning, where all you have to do is impute an image or impute a set of images, and then the deep learning, which is also a machine learning model, tries to find the characteristics, features between these different images that make them different. And then once it identifies these differences, it classifies them based on those differences. So for example, you have green apples, and you also have red apples. It identifies that these are apples, but this is a green apple of so species. This is a red apple of so species. It is also with deep learning that you make use of your facial recognition softwares. Two persons that look alike, even if they have your mobile device imputed in front of their face, or you put it in front of their face, if it is not exactly that same person, the mobile device will not unlock. Why? Because the computer has picked special features. Even though these two persons look alike, even though it's difficult for humans to identify the difference between these two persons, the machine tries to identify the smallest details and then use them to differentiate them. And then we have output. So deep learning is more advanced because this time it gets to think more. It gets to use more of the computer memory to identify the differences between these. But what are the different types of computer vision? Now, computer vision is way broad. There are different parts of computer vision. But in this session, I'll be talking about just very few of them. And I'll be identifying 6 of these. Now, the first I'll be talking about is optical character recognition. Basically, optical character recognition, what it has to do is your image, but this time it's a physical image. For example, you take a picture of a jotter, or let's say a banner. It's a physical image. What optical character recognition does is it picks out it scans through that image and picks out every single detail in that image. And then what it does is it fills in those details. It gives you those details. So let's say, for example, this is a specific image. This is an image. It could be maybe in a printed format. It could be probably an image, like in terms of a JPEG file or a PNG file. And once I upload it into my optical character recognition system, what it will do is it will scan through this image, pick these different sections. So for example, it picks this text, optical character recognition, and gives it out to me. Every single text in this image, it gives it out to me as text. So I don't have to, it saves me the time because I don't have to start, have my image and start writing it one after the other. All of the details that are in the image, it just gets them out for me. Now, there is another part called image detection. And in this part, I would more of like break the difference between image detection and recognition, and object detection and object recognition. There are two different parts. They do two different things, and I'll try to explain them as much as possible. For image recognition, you have your image, and there are multiple objects in your image. So I could have an image with bananas, oranges, apples, mangoes, and all of that. Now, what image recognition does is it identifies all the objects in that image and tells me, oh, these are the different objects in that image. So instead of just picking one image, one specific object, one specific item, it brings out all of them and tells me about all of them. But then object recognition and object detection, what happens there is it's detecting just one image. So even if I have 20 images, it is detecting just one of those images. Maybe the system has been programmed, the object recognition system has been programmed to identify apples. Even though I have 20 different fruits, I have different fruits, what it will do is it will identify just the mango or just the orange that I have told it to identify. So that's the very little difference between object image recognition or image detection and object recognition and object detection. Now, a very common part of computer vision which we have is facial recognition. Very, very common. Our mobile devices, when working, most organizations use them when you're walking into the organization and you don't have to use an ID card. All that happens is that it's all that happens is hello, can you hear me clearly?
Yes, we can.
Okay, great. So what happens in facial recognition is it picks up the specific image, the specific image of the person. Let's say the part of this person, as implies the face. So the face of the person, it tries to find key characteristics between that face and any other face. And if you notice, while explaining deep learning, I talked about the difference between your machine learning solutions and deep learning solutions. And while explaining deep learning solutions, I said the human does not have to tell it the key characteristics or features or differences between those images. The computer figures that out itself. So in facial recognition, it figures it out itself. It tries to find the difference between myself and my twin. It could be a difference as small as the distance between our eyelid and our eyebrows. Small difference. It could be the difference between the size of our nose. It measures all of these. So my nose is larger than my twin's nose, for example, if I have a twin. So it takes note of that and measures all of those in split seconds. And then once it finds out, oh, there's a difference between this person's nose or there's a difference between the eyelids measurement, then it doesn't open up. That's why in most cases, or you might have heard people saying that, or give scenarios where people had makeup on when they did the facial recognition, but then when they have washed their face late in the evening, you find out that they are unable to, open their devices, because at that point in time, it has picked that characteristic and then made use of it, but there was a change, and so it doesn't open up. Now, another section I would like to talk about is image classification. It's a little bit closer to detection and recognition, because then it's detecting and recognizing the content, but then it's classifying the different according to whatever details you have imputed to it. So for example, let's say for example, you have different images and then you want to identify which are fruits, which are foods, let's say which are wine and all of that. So it classifies them based on those characteristics. These are foods, these are wines. It classifies all of them together. It's more of a larger classification, not just object classification, not just one after the other. Picking one object, classifying it does much larger than that. And then we'll have object tracking. So for example, you give your system, my laptop, for example, or okay, my laptop cannot move. Let's look for something that moves. Let's say a puppy, for example. If you have a dog or a puppy, and then you take an image of it, it's wherever it goes, it tracks it. So the system tracks it. Oh, this is where it currently is, this is where it currently is. There are lots of others applications of computer or types of computer vision, and it's countless. There are countless. There are so many of them. At this point, I think I've said a lot. So I wanted to give some few minutes to see if anybody has any questions, then I could answer them briefly before moving ahead to the remaining parts of the slide. So let me see how many persons are currently on the call. Does anybody have any question at this point? If you have, you can just come off mute and ask your question. Any questions for me before I go on? Okay, so I believe the silence means there are no questions. So let's continue. Now, let's talk about the applications of computer vision in terms of real case scenario, use cases of computer vision. Computer vision can be applied in every single sector you can think of, like every single sector you can think of. Again, artificial intelligence, the power of artificial intelligence is limitless. As long as humans can do it, machines, to some extent, if not completely, can also be able to figure it out. For example, in healthcare, it's easy for people to identify. So instead of, I already have my system, my machine learning, or deep learning system, and then somebody has an illness. Let's say, for example, you are trying to identify a cataract in somebody's eyes. As we have noted earlier, first thing you do is to train such a model, you have to give it input. So I have which is in form of data. I have, let's say, 1,000 images of cataracts, and then I impute it, feed it into the system. What it does is, if I'm using a deep learning model, which is more of best now, it runs through all of those images and finds similar features. So once it has found those similar features between those 1,000 images, it uses them as the output. So whenever an image of somebody's eye, or maybe it could be the outer image of the person's eye, or maybe with a microscope seeing the inside of the eyes, it's then that picture is then uploaded into the system. It checks for those features, those key features that it has identified from that data, tries to see if it is similar, if there's something similar, or if it's in that specific picture that has been uploaded, and then it can tell me, oh, this person has cataracts or not. That's a very common use case. There are tons of other use cases affecting the healthcare industry that you can think of that can make our lives easier when it comes to computer vision. Or think about agriculture. Now, farmers need to know whether their plants have a disease or not. I could have a robot, not necessarily a robot, but one thing, just a disclaimer, when I'm talking about robots here, I do not mean the human robots, that we see in movies. Robots could be as small as a car. It could be just a moving object with a camera in front of it. So don't get me wrong. Don't think when I mention robots, I'm talking about a giant character. No. So I could have a little device that moves around, and it goes around the farm. Let's say I have a cassava plantation or a plantain plantation. And what it does is, with those inputs that have been embedded into the system, it checks each of the plants and tries to figure out which of them has those details or those features. And then if it identifies that any of them has those features, it flags them as having that disease, which makes it way easier for me when whenever I am trying to work on my farm. I don't have to start thinking, I don't have to start, predicting something that might not be right, making predictions that are not right, that are not correct. And then for insurance, computer vision can identify past records of a person. So somebody in advanced countries, has this person be able, what is this person's a damage, for example, an accident occurs. What is the damage of the car? And then, oh, this is the damage of the car, this is this. It's easier for companies to identify that, oh, this person is what, this is the worth of this person's car. And then what it does is it doesn't have to wait till hours. Unlike humans, the system doesn't have to wait hours before the car has been damaged. It could be a system that immediately the car is damaged, takes a picture of it, and then it's able to identify the worth that the person can be insured for. It also identifies if the mistake or whatever happened was as a result of negligence on the part of the person, or it was just, an unforeseen event that was not predicted for. Manufacturing, the different, so for example, in large manufacturing organizations, you notice with larger machines, you notice patterns, or your items are moving from one stage to another, Computer vision makes it possible. So when it is at this stage, it moves to the next stage. Computer vision system knows, oh, it's already ready at this point in time, so it should be going to this next part of the manufacturing list. It's in that case, it doesn't, I don't have to wait. Unlike humans, I don't have to wait till maybe I perceive a specific smell before I know it's ready, or it's at this centigrade before I know. No, computer vision makes all of those easy. Banking sector, for verification, somebody comes to take a loan, and I can pick a picture of the person. If there are already existing records of the person, say for example, the country has a central database identifying each person's record, then when the person comes to ask for loan, I can run through the person's image, I can run through the person's database. Oh, has this person owed before? Is this person somebody that pays back? What is the track record of this person? Any crime? Has this person committed any crime? What is the crime? All of that. It's easier for the banks to be able to administer loans and all of that. Very common example in terms of automotives or self-driving cars, different type of self-driving cars. For example, we have cars that are very advanced to the extent that they can identify with object recognition, objects and image recognition. They can identify every single thing on the road, and you don't have to touch the steering. You don't have to make use of your throttle, your brakes, and all of that. It picks the distance between itself and the next image, and if it's closer, it automatically presses the brake and stops. If it notices that the light is changing from red to green, it takes note of all of that. So computer vision, it's like having its eye of its own. Computer vision makes use of that. And then we also have surveillance. Your organization, very common example, security cameras. So picking pictures of and trying to identify people. But then there's an advanced part of surveillance, and what it does this time is it picks the images of people, but then it classifies them. So for example, in an organization, I work in an organization. What it does is it already has my image in a database. And so when I stand in front of the surveillance camera, it picks my image, runs through the database it has, maybe a database of employees, and then checks if my image is there. If it identifies my image, it opens the door and lets me in. Another example is also identify people who who are dangerous. So for example, I have this computer vision system in form of a camera. It can see somebody, and from facial expression identifies how the person is feeling, what the person could be thinking, and then it's able to tell me if that person is dangerous or not. Now, I said a lot, but in this session, what I basically wanted to do is also show you in terms of how these systems work. Now, Microsoft has what we call Azure Custom Vision, which is a computer vision system that enables you identify images, that makes use of computer vision to identify images. So what I will do here is run you through the custom vision, run you through briefly how the custom vision service works. So just give me 1 minute, please. And I'm going to reshare my screen. Then I'll quickly show you how it works, so you can see. So again, while I'm trying to reshare my screen, if you have any questions from what I've said, from what I've mentioned, please, you can unmute now and ask. Okay, so I'm going to share this again. Please let me know when you can see my screen.
I think there's no question in the chat.
Yeah, I'm trying to share my screen. Can you see now?
Yes, we can.
Can you see my screen?
Yes.
Okay, great. So Microsoft has a website where you can test out all of these features. So I'll head over to customvision.ai. And what I'll just do is briefly show you what it's like. Again, building your computer vision system is way large. You know, it's more of, it takes time. So what I'm doing here is making use of an existing computer vision system, which is custom vision that Microsoft has. Hopefully in subsequent classes and in subsequent sections, we would be able to, you know, work on it. Now, this is a machine learning system. As you can see, all you have to do is giving your input, as I mentioned earlier, giving your input, you're uploading different images. And then with those different images, Microsoft Azure cognitive services, computer vision makes use of, trains the system, and then tries to identify key characteristics with it. And then it's way easy to tag the different images based on the characteristics that has been identified. So I'll sign in with my Microsoft account. And what we are going to be working on is an image classification system. So I'll sign in with my student ambassador account just to show you what the custom vision service looks like. I hope we really have some time to walk through this, but just in case we don't have some time to walk through this, then I'll just pause wherever time lets me get up to. And this is what the custom vision service looks like. I can create a project, but before I do so, I'll head over to Microsoft Azure, so portal.azure.com. And what I would do here is I would create a resource, a computer vision resource. So I'll sign in. Again, I'll be moving a little bit fast just because of time. If you need to check out all I've worked on, you could probably get the recording and then check how you could create it. So I'll click create a resource, and then I would look for cognitive services. Yeah. Search for it. Let me know if you can still hear me, please. And so what I would do is I would create a cognitive service. And then what I'll do is, okay, let's add it under this resource group. You can create a new resource group if you don't have one. And let's name this test computer vision system. I'm pricing tier S0, click this, and I'll review and create. And so what it does is it will create this resource for me. What you do is to create the resource for me. So let's wait a little bit. And then I'll click create. And then what it will do is it will deploy that resource. So just pause, wait a little bit while it's trying to work on that. Now, you could basically what this will do is if you need to embed this into your application, it's lots easy. So that's why we need to create a resource group. I will not be showing you how to embed it into your application again because of time, but then I just wanted to show you how to create a resource group. So if, for example, you are working on a project, it could be a school project, it could be an organization project, you could have your interface and then just connect it. What it does, it will read and write to that that has been created. Great. So now let's go over to the resource. And what we're going to check for here is the keys and endpoints. This is a very important section. So when you cover to resource management, keys and endpoints, if you are creating your application, these are the keys you make use of. So it's somewhere in the application, whether it's a web application or a mobile application, whatever it is, you have a specific section where you can input these keys. And the moment you input these keys, it would connect to this resource that has been created. So now that I've created a resource, let's head over and create a new project here, a custom vision project. And we're going to give it a name. For the last one we created, we gave it test computer vision system. And then a resource. Okay, so I'll reload this. Let's create the resource again. I think we should have, has this resource group been created? Okay, so it's still loading. So just wait for some minutes. And let's see if it finds or it is able to detect this resource group that we have created. So let me reload this again. Okay, so it's still yet to identify it. So let's head over here again and create a custom vision resource group so it's easy to identify. So I'll come here and create a custom vision resource group. So custom vision. And then let's add it to this resource group. Let's give it a name, tests, computer vision system, training resource, training price tier, standard 0, prediction price tier. We're making use of free. So let's review and create. And oh, sorry, we missed something here. What are we missing? Oh, okay, this is already in use. So let's add one to it. Again, let me copy this. Do we still have some issues? Why is this coming up? So let's click on review. Somebody trying to say something. I don't know. Okay. So we'll just wait for some time for it to create it, and then we'll see if it can identify it this time. Great. So I'll click on create. And while this is reloading, I will delete this. Okay, so I think this has been created. Let's go back here. It should have been created by now. Okay, so deployment in progress. Okay, great. So just wait a little more for it to get done. Great. And if you notice here, we can see the system has been created. So I'll give it a name. So we copied the name earlier. Don't worry about the description if you need to. And notice some specific features here. First, we've given it our name. Our description, we say we're leaving that out. The resource group, we have given it, we have assigned it to the specific resource group that we created. And then notice that what we are doing is we could decide to do an object detection system, as I mentioned earlier, but this time we're classifying the images, multiple classes. So there are different images, and so we're identifying them classifying them based on their different characteristics. So that's what this means. And then we're making it general. Okay, so let's make it food just so it's a little bit smaller. And so we'll create our project. And then what happens is we are going to upload different images. So what is going to happen is there's a link. I'm going to get these images from aka.ms/fruit-images. So it should, we already have a couple of images there. So I'll just download this. And then once it's downloaded, what I would do is I would extract. So I'll just come here so where it hasn't downloaded. Okay, so let's do it over here. So add images, and I will just extract from here instead. Okay, sorry, I can't see it from here. So let me go over to my download section. Sorry, you might not be able to see me extracting it because I'm currently sharing this specific screen. So I just extracted it. And what I'll do here is under downloads. So under downloads, training images, we can see the different images now. You can see apple, you can see orange, you can see banana. Now, I would open up the Apple folder and select all of these, open. And then what it will do is it will add all of these images. I place a tag to it, so Apple. So whether it has red color or it has a mixture of red and green, which is another species or another type of apple, so it's just thoroughly green, it should identify it as an apple. So I'm uploading this, and this is uploaded. What I will do next is I will do the same for oranges and for banana. So again, add images, go over to training images, banana, copy, okay, place a tag, banana, upload. Now notice that we're feeding, in this process, we're feeding our system with a lot of data. Again, it has already been built for us, so we don't have to do majority of the work. Again, I add more images, and this time I'll add the oranges. Now, something else to take note of is that as I'm adding these images and including the tags, what happens is you notice so let's this upload while I show you. You notice somewhere in this section, each new tag is added, and then the specific tag is placed on the specific image. Now, let's test our image, our system. So we'll train. And well, to save time, let's do a quick training. So I'll close this. So wait for some time for it to get done. Still training. So we'll give it a little more time. So while it's training, if you have any questions, you can ask now. If you have any questions, you can just unmute and ask them. To take some time to train this. If you're having larger systems, it might take a whole day. That's why majority of times it's best to train in cloud. So even if your physical system goes off, the training model or the model can still or would still be running. So oops. So let's try this again. La 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 la. Still training, still training. Okay. Okay, I'm currently notice. Go faster, go faster. So we just have to give it some more time while it's training. Okay, so while it's training, instead of staying idle, I think I would like to have with everybody on the call. So I think we can unmute and talk about our experience with machine learning, with artificial intelligence. Have we had an interaction with artificial intelligence? Have we gotten to work with a machine learning, a computer vision model before? If you have, would you like to share your experiences here? So while we wait for our model to finish training. I'll leave the floor open so anybody can just unmute and talk about their experience. If you are beginners, if you are at intermediate stage, or you're advanced than I am, then you could just let us know. So who would like to go first, please? Anybody like to go first? Okay, just to confirm, can everybody hear me clearly? Can everybody hear me clearly?
I can hear you.
Okay. So I don't know if every other person on the call can hear me clearly.
I can hear you from my hand.
Okay, great. So who would go first? Since everybody can hear me, who would like to go first? Our machine learning model has finished training, but then I just need to hear one person before we continue. At least one person. Not Mr. Shei, not Paul Barnabas, somebody else who would just like to talk about their experience before we go on. So who would like to represent everybody on this call? Seems everybody is really quiet.
Maybe you need to call by name.
Okay, I was actually trying to avoid that, but I think that's the only option I have left now. Okay, so I like the name Emmanuel, and I can see Emmanuel DME. So please, Emmanuel, would you like to tell us, have you had an interaction with machine learning, artificial intelligence, computer vision?
I'm in a meeting.
Hello, Mr. Emmanuel. Are you there with us? Okay, so I think Samuel unmuted some time ago. So please, Mr. Samuel, can you just continue?
Okay. Sorry, I lost the question. I was having network challenge then, so I could not pick the question you might have asked.
Okay. So what I'm saying is, have you had an interaction? Have you got to work with an AI system when it comes to building computer vision systems? Are you a beginner? Are you an intermediate? Have you gone advanced? Have you built larger systems?
I'm a beginner, let's say, because I've not worked on artificial intelligence, except that I have been reading a lot of AI, but I've not worked on it.
Okay, great. So Mr. Emmanuel has unmuted now. Please go on, Mr. Emmanuel.
So I didn't really hear everything you asked. Could you come again, please?
Okay, so I was asking, when it comes to computer vision, artificial intelligence, what is, are you a beginner? Are you an intermediate? Have you gone to the advanced level? Like, have you built amazing solutions with it? if you have, you could share one with us.
So I'm a beginner. Just diving into programming. So I'm still a beginner. Just learning.
Okay, great. Thanks for sharing with us. So thank you very much, Mr. Emmanuel, and thank you very much, Mr. Samuel, for unmuting to share with us. Okay, so let's go back. Just wanted to, break some ice so the seriousness is not too much. Now, if you notice, it has run through the 45 images we uploaded, 15 for oranges, 15 for banana, 15 for apple, and then identified them. Now, let's quickly test this. And what I will do is I'm going to upload 2 different images. So let me download an image of a mango and upload here. So images, so let's see how well our system has been trained. So I'll just download this, save this. And then I'll download another image of banana, apple, orange. Which do I download? Let me download banana. Banana. Great. I think this looks like a nice image. Let's see if we can steal this from here. Oops, sorry. It's not coming out as a JPEG format. So I think we just have to go back here, which they will pick. This looks nice. So let's go with this. JPEG. So I'll copy here. Now, impute an image URL, or so I've downloaded the image, so it doesn't need to stress itself. I just come here, downloads. So first, let's put the correct one. And notice what it does. Well, it picks, or it predicts that this is an apple. It is 93.9% sure that it's an apple. Okay, so now let's try to understand why the machine does it this way. If you go back to the images we uploaded, notice that our apples has the same color as this. Our apples has the same colors. So let me just go back and show you. Take note of this. I think I should duplicate this so you can notice the difference. So give me 1 minute. Let's go back to our apples. Come down here. Apple. And okay, so we just have 3 apples here. What happened to our other apples? Okay, so I think I should just show you the image I have. Okay, so if you notice from the images I had, and I actually mentioned it earlier, I said whether the apple has it is green or is red, or it is a combination of the colors, it would still identify them. I think I should show you a picture. So I'll just share this screen and show you a picture of what I'm talking about. Come here, window. And great, you notice this. I don't know if you can see this image. Can everybody see this image now? Can everybody see this image?
Yes, you can.
Okay, great. And if you notice, it has this, it looks exactly, or in terms of color combination, like the banana. So it's well, kind of understandable for our machine. Sorry, this is the wrong screen. It's kind of understandable for the machine to act that way, although it is not correct. But then we can still train our model more to be able to identify more. Okay, so now let's impute a banana and let's see what happens this time. And then this time it is very, very sure that it is a banana, 99.9%, which is more of like 100% sure that it is a banana. Let's try one last image. Let's try watermelon. Maybe a watermelon would. Something else to note is that our model is not an object recognition model, an object detection model. It is a classification model. So what it does is tries to classify the image based on images we have. What are you trying to say something? Okay, sorry, I think Mr. Paul. Okay, great. Sorry, I had to mute you, Mr. Paul, because of the echo. So it's classifying these images based on the different segments that we have. So let's see which watermelon looks nice. Let's take this. I'll save this and then put it here. And then let's get over to our model, browse an image. Where is our watermelon? And let's see what our model thinks. Okay, so this time, well, it's saying it's 70% a banana. I don't know the reason why. Apple and all of that. So it goes to show that what I'm just trying to show is that as our model, again, so one of the reasons, something to mention, one of the reasons why I think it picks the banana instead of others, or it picks the banana more, it thinks it's a banana, is because of the shape. If you notice the bananas we uploaded, so let me quickly show you a picture again that shows the reason why the system must have picked that. Let me know if you can see this screen. So if you notice from this screen, can you see this screen?
Yes, we can.
Yes.
So if you notice, banana has more of like the shape. The watermelon has like this curved shape of the banana. So yeah, it must have been confused and then classified it to be that. But then if we're making use of an object detection system, which is a whole system, it will not classify them. Instead, it will identify, detect, identify, and recognize this specific image. Okay, so now I've been able to show you how a very simple example of how a custom vision AI service works. So it's easier when you're making use of existing systems like this, it's easier for you to build your models. You're making use of low code, but then if you need to build more complex systems, you might need to write lots of code. So this is the last part of this session. I think I've run past time already. Okay, yeah, it's almost time. So I'll leave the remaining time for questions.
Yeah, you already
I
run
still have time, Mr.
past
Shi.
the time.
Do I?
Yeah, you have already run past the time. But
Okay.
we can allow you to, if there's any question in the next 5 minutes, we can take question and wrap the section up for this week.
Okay, great. Thank you very much. So please, if there are questions, you have the floor now. So ask your questions. Yep. I can see someone's hand up. Please, Samuel, go on.
I want to ask a question on the compute vision and the connective service. For what I does the compute vision, does it does the same function, the same thing with the connective service too?
Okay, so I meant custom vision. That's the correct name. So
Oh, okay,
cognitive
yes.
services contains more than custom vision. Again, if you came earlier while I was explaining what computer vision is about, I talked about object detection, image recognition. You also have image classification. When you have, for example, you have video indexing. Yes, that's another section of computer vision. Video indexing. You have things like facial recognition. So what cognitive services does is all of these, it brings them, it more of like gives you a platform to do all of this. But custom vision is just one out of the so many services in cognitive services. I hope that wasn't confusing. Was it
Okay, I
confusing?
get the answer.
Hello, Samuel. I don't know, was it confusing? Did you get that?
Yeah, I get it now. Thank you very much.
Okay, great. You're welcome. So, any other questions? If there are no questions, you might be trying to figure out the questions. I know some persons here said they are beginners, so you might still be trying to get used to all of this. I'll be dropping the link to my LinkedIn profile and then my Twitter handle. You could reach out there and I will be sure to respond to the questions at any point in time. I think I just dropped it in the chat. So just in case you have questions in future, you could just reach out.
Okay, thank you, Chaplet, for this insightful understanding and training to be able to help us to have a better understanding of how AI, especially this aspect of the computer vision. Now, what I can deduce as a summary is that when you are looking at accuracy in terms of object identification, from what Chaplet said, it's better you use the identification aspect of the computer vision, where it can easily identify that object and also be able to classify it. But if you use classification, from what it shows, and you can see several factors that we can consider as inaccurate. That for banana, because it's curved, and the watermelon he uploaded is also curved. By the virtue of those characteristics, he was able to identify it as a banana. And you can notice when it was identifying the apple in the order with a mango, with that order, or I think it's a mango or orange, you notice it was looking at the colors. The colors that we have in the apples are red, green, I think, and yellow. And those are the combination of the color that is the pigment of that mango. I don't know whether it's a mango, and it was identifying it as what? As apple. So just as I said in summary, it is like a continuous learning process for all of us, especially for the beginners. And we have started with the foundation. Next week, we are continuing with another speaker that will be taking us further in understanding this before we get to the complexity of developing. But however, you can easily go to Azure Cognitive Service or custom. It will drop, Jefta will drop the link here. Just go to the site, try to make yourself busy, get your hand dirty, go to the site, whatever try to try it out with different classification of objects, maybe mango, maybe fruit, or anything you can see appealing to you. And that is customvision.ai. Try it out. And when we come next week, at least you have a reason to talk in terms of what you have learned through that process. And finally, I also want to remind you that we also have a program coming up by 5 p.m., precisely 5:15, called the Grassroots Innovation. Now, this is a program where you learn from experts that speak to us regularly on our social media, and they'll tell us how they became what they are. And you can see it on the chat. Just you can come online through YouTube if you are YouTube Live, Facebook Live, or LinkedIn Live, depending on the social handle that you are used to. Please copy it out, and I'll be expecting all of you in that track by 5 p.m. so that we can all learn from those people that have gone before us. In absence of any other thing that, if except Paul want to say anything, I think we're sorry for we took some time. We are supposed to finish by 1, but because we started, I think 10 or 15 minutes after 12, that's why it could spill up to this time now. So we apologize for that, but we encourage you to come on time next week and ensure you are here at 12 sharp so that we can commence on time and we can also close on time. Paul, do you have any? Okay, since there is no other thing, I say have a lovely day and have a wonderful weekend. Bye. Everybody, bye.
Hello, Mr. Sheikh. Can you hear me clearly?
Yes, I can hear you.
The recording.
Yes, it will just connect with Paul. He will get it to you.
Yeah, I mean, like you've not stopped the recording.
Oh, wow. So thanks.